Here we are about to learn about how to solve systems of equations using the method of elimination. Remember, you can use any method that you wish. This is just one of them. All right, so we've got a couple examples here. Here's one of them. All right, with the method of elimination, our goal is to take these two equations and combine them together and eliminate one of the variables. So as you see here, we have two variables, x and y. We're going to eliminate one of them. It does not matter which. So if we were to combine these numbers straight down, which one would be eliminated right now? So if we were to add, remember we're adding all of these together. So we would take negative 5x plus a negative 3x. That would give us a negative 8x. So that would not disappear right now. Same thing with the y's. If we add those together, we would get a 7y. So in fact, neither variable is eliminated. So we have to change that. Now, some variables are easier to eliminate than others. You just need to pick one. So I'm looking at this and I see, well, the y's are very similar. The top one is just missing a negative 6. If that was the case, it'd be really easy to eliminate the y values. So you can try that. I'm going to kind of go the more difficult way this time, just so that way we can see it. I want to eliminate the x's. So between a negative 5x and a negative 3x, we want those coefficients to be the same number. I know that 5 and 3 both go into 15. So I'm going to multiply this entire equation by 3. And the entire second equation by 5. Now when I do this, and I distribute all of those numbers, my x's would be a negative 15x and also a negative 15x. And if I were to add those together, the x would not eliminate. So what we need to do then is to multiply one of the original equations by a negative. I'm going to pick the second one, and it doesn't matter which. This way, when we distribute the negative 5, it will actually give us a 15x positive, meaning that when we add these two numbers together, it's going to disappear. It's going to eliminate. So we just need to write the rest of the equations. So it'll be plus 3y equals a negative 6, and a minus 30y equals a positive 60. So now we're just going to combine these two equations together by adding them straight down. Negative 15 plus 15, that's going to cancel out. It's going to eliminate. 3y minus 30y is a negative 27y. And that's going to equal a 54 when I combine those constants together. And now we just solve. Divide both sides by negative 27. Y is going to equal a negative 2. Now this is going to be very similar to the substitution method. Now that we know what one of the variables is, we're just going to substitute into one of the originals. So I'm just going to take the first equation and substitute what we know, which is negative 2 for y. And of course, we just solve, and x is actually going to be 0. So our two values are 0, negative 2. Make sure you check your answer by substituting both of these values into both equations, not just one, both of them. And we'll see it as our correct answer. Now, another quick example here. Once again, you can use any method to solving the system that you want. This is just one way. All right. So, looking at this, I'm going to try to eliminate the x's again. Between 4 and negative 10, I know that those numbers both go into 20. So I'm actually going to multiply the first equation by 5 and the second equation by 2. Now, if you saw a different number that 4 and negative 10 can both get to, that's perfectly fine. You might just be dealing with larger numbers. It's okay, we're going to get to the same answer. When I multiply these out, I'll get 20x plus 80y equals 60. And negative 20x minus 80y equals negative 60. Once we add these, combine all these values straight down, I notice that the x's eliminate, which is what I wanted. But I also notice that the y's eliminate. So that means there's nothing on the left-hand side of that equal sign. And when I add the constants together, that also equals 0. So what does that mean? This means that every value you can think of will work for this system. So our answer is infinitely many solutions. In another video, I talked about how both variables disappeared and the two numbers we had did not equal each other. And that meant there was no solution. This is very similar, except now when we look at this final equation here, we know that this is true. We know that 0 does in fact equal 0. We know 10 equals 10. If this final statement is true, the answer is infinitely many. If this final statement was false, there would be no solution.